Okay. Hello. Yeah, dear students, everyone, pleasant morning. Welcome to Infinity Learn by Sri Chaitanya. Right, dear students, we have been doing the sessions related to, a special series where 60 minutes into 10 session is, you can say, 60 marks, right, dear students? We've done certain topics already: binomial theorem, vectors, 3D geometry, statistics, we can say inverse trigonometric functions. All these things are done, and today's topic, now in this session we are going to highlight probability topic. Coming to probability part, one important thing I would like to share, dear students. Most of the students feel that like they are not perfect in permutations and combinations, so we should give up probability completely, which is absolutely wrong, my dear friends. Actually, probability topic, if you take, we can divide the topic into three categories, three parts, of which major permutation combination related questions will be of only 1/3 of the part, and 2/3 part, if you are just aware of permutation combination, simple applications are enough to answer the question from probability, dear students. Let us see the important statistics related to probability here, right, dear students? Chalo, you see, in probability topic, I have consolidated, you see, the major topics are also these, my dear friends. You see, first one, classical definition, permutations and combination based questions. You see, classical definition of probability, that means permutation combination based question, there are 42, and addition theorem, conditional probability and multiplication theorem, and independent dependent events, Bayes theorem, probability distributions, and binomial distribution. These are the topics that I have taken, dear students. There are majorly seven areas in, probability topic, dear students. Now we'll see the distribution of previous year questions. The last 2010 to 2024, 14 to 15 years questions I have taken. Of these, my dear friends, you can see the first one, classical definition related questions, there are 26%. I said 1/4, my dear friends. That means to answer these questions, definitely you need some sound knowledge over permutation and combinations, because basically these are permutation combinations related questions only, dear students, this part. Whereas secondly, addition theorem is like in sets, N of A union B kind of, P of A union B formula, P of A plus P of B minus P of A intersection B, and P of A union B union C. Relevant problems, you got 10 questions, that is 6%. Then conditional probability, which is a very simple synopsis kind of. You don't require much of theory for conditional probability things. Simple algebra is sufficient to attempt this question, my dear friends. There are 14 questions from this, my dear friends. Then independent dependent events, that means you can see here also there is no theory, 1 or 2 points, simple 1 or 2 points are enough to answer these. You can see these three items together, my dear friends, 27, that is, you can say 33%, which is more than this. Exactly 1/3 part is together, these three, my dear friends. Together, addition theorem, conditional probability, independent events, dependent events, almost there will be no theory, simple definitions and simple formulae are enough. If you are able to understand the question, you can comfortably answer these questions. I'll show you how to solve those questions, my dear friends. The next important is Bayes theorem. Total probability theorem and Bayes theorem, we can say almost together, dear students. Yeah, you can say 14 questions on this. Then interesting point is probability distributions, 15%, and binomial distribution, 17%. You see here, so easy part it is. These two together, very easy part this is, you can say almost 32%. So if I am not, it is very much confident in probability, but I don't leave the topic, I do these two topics well first, because probability distributions and binomial distributions are a very easy kind of, you can do these, dear students. After that, I will focus on this part, then thirdly this. So dear students, my point is to answer a question from probability, the chance to get a question from other than core permutation combination is 0.75. 3 by 4 is the probability to get an easier moderate question, my dear friends. Right. So dear students, please do remember, you see, this topic is going to be mostly easy in the exam, and even in advance also you can find most of the questions are very easy, my dear friends. Coming to important points, classical definition in the sense, my dear friends, classical definition is very simple. You know, after knowing the basic terminology of probability like sample space, event or outcome, elementary event or event, mutually exclusive events means A intersection B is empty, exhaustive event that means A and B is S, and basic things after knowing this. So we define probability of a particular event P of E is defined as number of favorable cases of the event E by total number of cases in the sample space. This simple definition is enough, my dear friends. See, simple definition is enough to answer questions related to classical definition or permutation combination based question, my dear friends. Right? Let us see a few questions here for your convenience. You see this? The coefficients ABC in the quadratic equation ax square plus bx plus c equal to 0 are from the set 1, 2, 3, 4, 5, 6. The probability of this equation having one real root bigger than the other is P. Find 216P, my dear friends. That means A can be any one of those 6 elements, B can be any one of those 6 elements, C can also be. So A, B, C can be taken in 6 cube possibilities, 216. This is why he has given 216P also, my dear friends. I just want one real root is bigger than the other root, in the sense roots are comparable only when they are real numbers. That means that this particular equation must have two distinct real roots, my dear friends. Two distinct real roots means discriminant b square minus 4ac is strictly positive. B square must be greater than 4ac, dear friends. You just try to count the number of cases. Suppose B is taken as 1. If B is 1, 1 square greater than 4ac is impossible because AC minimum should be 1. So this is not possible. Similarly, B is equal to 2, my dear friends. If B is equal to 2, this is 4, and here least possible value also 4. I just want B square strictly greater than 4ac. So this is also not possible. If you take B is equal to 3, B square is 9. So 4 is there. AC can be, in this case, AC can be 1, AC can be 2. AC 1 means A comma C ordered pairs 1 1, 2 means 1 2, 2 1. So altogether 3 possibilities here, dear students. The next, if B is equal to 4, if B is equal to 4, this is 16, AC must be, you see, AC can be less than, this is already 4, so AC can be less than 4, my dear friends. AC less than 4 means you can take AC is 1, 2, 3. So AC 1, you know, one possibility, 2 also 2 possibilities, and 3 means 1 3 3 1. So you will get 2 more possibilities. That means here you got already 3 possibilities, here 5 possibilities, my dear friends. Then if B is equal to 5, this is 25. So AC can be up to 6. That means AC can be 1 2 3 4 5 6. Already up to 1 2 3 5 are there. 4 means 1 4, 4 1, 2 2, 3 possibilities. 5 means 1 5, 5 1. 6 means 1 6, 6 1, 2 3, 3 2. You see 1 2 3 4 5 6 7 8 9. Apart from this 5, you will get 9, means you will get 14 possibilities here, my dear friends. B is equal to 6. If B is equal to 6, this is 36. AC can be, you see, 36 by 4 means AC can be up to 9, my dear friends. Because 9 you cannot take, exactly 36 you will get. AC can be up to 8, my dear friends. Already up to 6, 14 are there. And then 7, in the sense 7 is not there here, 1 7 7 1. 8 possibility, that is 2 4 possible, 4 2 possible, then 9 means 3 3 possible. So you can add 3 more to this, that means 17. You just add all the cases, my dear friends, 20, 34, 39. So you will get, my dear friends, 17 plus 3, 20. So that is 39 you are going to get, my dear friends. So accordingly, you just see the cases, you will get that number is 39 by 216 into this, my dear friends. You are going to get 2 4 4 2 will become 8, 3 3 is going to be 9. So you will get like this. So just count the number of cases, you will get P is nothing but this number by 216. So you will get the answer, dear students. So this is purely permutation combination based question. You see one more question here. 12 identical balls are to be placed in 3 identical boxes. Then the probability that one of the boxes contain exactly 3 balls. So what is the case, my dear friends? 12 identical balls and 3 identical boxes. For your kind information, 3 identical boxes. So one of the boxes contain exactly 3. So you take 3 and selecting 3 is one way, putting the boxes is also one way because all are identical. So now you are left with 9 balls. 9 balls are to be kept in 2 boxes, my dear friends, such that one of the boxes contain exactly 3 balls. Now 9 balls are to be distributed into, my dear friends, total number of ways of distribution you have to take in the denominator. So actually each ball can go into, dear students, so 9 identical bars are to be distributed into 2 identical boxes. In how many ways we can distribute, my dear friends? You can see 1 8 1 combination, 2 7 1 combination, 3 6 1 combination, like that. 8 1 0 9 is also one possibility, 9 0 also one possibility, my dear friends. 10 cases you are going to get. In each case, actually if the boxes are identical, my dear friends, the total number of ways of distributing is, so you have to divide into 3 cases, such that you see even these are identical cases. So in this problem the point is, if the boxes are identical, the cases you need to split into cases like, you see, 0 0 9. Yes, because you won't get again. So suppose 0 you put 0 9, then again, so already 12 balls are there, you need to split into 3 cases, right? Already 12 identical bars. In how many ways you can put into 3 identical? 0 0 12, 0 1 11, 0 2 10, like this. You have to go with 0, this is 12 0, right? So in these many ways you have to divide the number of cases. In those you have to take where one particular ball is going to take 3. So you have to take, my dear friends, I think here he has taken the cases where the boxes are not identical. So this is why he is getting these 3 by 11 kind of cases, because if each ball can go into any of the 3 cases is going, otherwise you won't get these many. Here boxes are taken not identical. If the boxes are taken identical, the cases you need to count like this, and you fix one of the boxes to be 3 and count the other things, my dear friends. Then next you see this, the probability that 2 randomly selected subsets of the set have exactly 2 elements in their intersection. You see here, so 1 2 3 4 5 elements are there. So 2 randomly selected subsets of the set. Actually if you take 2 subsets of this, every element has possibility. It suppose A B, it can be in only A or only B or intersection or outside also. For every element there will be 4 possibilities, my dear friends. So you are going to get 4 power 5 total number of cases, but he wants exactly 2 elements in that intersection. Which 2 out of 5 you select 2, my dear friends? Those 2 elements, suppose 1 2, it must go here and here only, one possibility. Then, my dear friends, you are left with 3 more elements. These 3 elements must be anywhere here or here or here, but not here. So 3 possibilities, you will get 3 into 3 into 3, my dear friends. So which you can say 5C2 is 10 into 27 by actually 2 power 10. So you can say, my dear friends, 27 into 5 is 135 by 2 power 9 is the answer, dear students. Need to understand the question properly, accordingly you attempt the question. Right, dear students? So like this, even there is some ambiguity in the previous question, but here all these first level of questions will be related to purely you can say permutation combination based questions. The next, my dear friends, addition theorem, in the sense you know well, probability of happening of A or B, that means P of A plus P of B minus P of A intersection B, right? And similarly, P of A union B union C will become P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C, my dear friends. Okay. Next, dear friends, you see this question, you see integer is chosen at random from integers 1 to 50. The probability that the chosen integer is multiple of at least one of 4, 6 and 7. You see here, I will give the idea here how to solve, dear students. An integer is chosen at random from 1 to 50. Fine, okay. So total number of selections will be 50. Now probability that the integer is a multiple of at least 4 or 6 or 7. So it must be multiple of at least 4, 6, 7. Since the set is small, you can rather n of A union B union C, you just take multiples of 4, my dear friends. That means you will get 1 to 4, 8 to, you can say 48. There are 12 multiples of 4. And multiples of 6 which are not covered here, 6 is not covered, then 12 is covered, then 18 is not covered. Yeah, so this is 24 is covered, 30 is not covered, then again 42 is not covered, then again 48 is there already. So other than these 12, my dear friends, so you are getting 4 more numbers, 6, 18, 30, 42. So 12 plus 4 and 7 also, it must be divisible by at least one of them. 7 multiples, 7 is not covered here, 7, 14 is not covered, 21, 28 is covered, 35, 47 is covered, so 49. You will get 5 more elements here, my dear friends. This is going to be, yeah, you can say, so this is 9 plus 12, that is, you can say 21 numbers are there which are divisible by either by 4 or by 6 or by 7. So 21 by 50 is the probability. Actually, if you want to do this, you can also use addition theorem, but rather you can do it here directly, dear students. Next, dear students, see same kind of questions. Here you can just see, my dear friends, A, B, C, B, 3 events such that the probability that exactly one of A, B occurs is 1 minus k, exactly one of B, C occurs is 1 minus 2k, and exactly one of C, A occurs is 1 minus k. The probability of A, B, C occurs simultaneously is k square, where k is between 0 to 1. Then the probability that at least one of A, B, C occurs. This can be explained, taken or solved with the help of Venn diagram, my dear friends. So what is given? First, whenever you take Venn diagram, try to take the data from the innermost. The probability, you see, probability of A, B, C occur simultaneously is k square. This is k square, dear students. Fine. The next, where k is between 0 to 1, of course. Then probability exactly one of A, B occurs, A, B, C 3 events such that exactly one of A, B occurs is 1 minus k. So either A but not B will become 1 minus k, my dear friends. Exactly one of B, C occurs is 1 minus 2k. A probability of exactly, you see, one of C and A occur is 1 minus K. This is what the data is given, my dear friends. Now, A, B, C occur, so at least one of, you see, that means at least one of A, B, C is nothing but P of A plus, probability that at least one of them A, B, C occur means P of A union B union C, my dear friends. So, he is asking about P of A union B union C, dear friends. So, this must be sum of these three plus these three. Together, it must be, dear students, of course, less than or equal to 1, from which you will get an inequation. Here, first of all, these three sum must be less than or equal to 1. This three sum, and each one must be greater than or equal to 0 and less than or equal to 1, my dear friends. So, you can just try, this sum is going to be, this is 3 minus 5k, you just see 3 minus 3k, this is 4k, 3 minus 4k plus k square, this value must be positive and less than 1, right? This must be less than 1, obviously. So, you will get, my dear friends, k square minus 4k plus 2 must be less than 0. So, you will get some range of k value here. Similarly, my dear friends, so you need to apply the other combinations, you need to check, and each one, this must be greater than 0 also. This value, sum of these three must be greater than 0. That inequation will also help you to derive certain conclusions here. So, the point is, you take the help of this. So, you try to take this is minimum to maximize this. If you take these areas minimum, you will get the maximum area here. Accordingly, you can find the value of k, my dear friends. Okay. Next, you see conditional probability in the sense, my dear friends, you see P of A given B. That means here I am just giving the central idea, because you see P of A given B in the sense, when B has happened, when it is given that B has happened, what is the chance that A will happen? So, you know, this is mathematically P of A intersection B by P of B, my dear friends. P of A intersection B by P of B. Or similarly, P of B given A in the sense P of A intersection B by P of A. The same is written with the help of multiplication theorem, that P of A intersection B is P of A. A and B should happen, A should happen, after happening of A, B should happen, right. Similarly, suppose if you want P of A intersection B intersection C in the sense, so what is the probability that A and B and C should happen? This is, you can also write A should happen, after happening of A, B should happen, after happening of A and B, C should happen. This is what we see, dear students. With the help of this, you take up this question. Yeah, you see, a fair die is tossed repeatedly until a 6 is obtained. Okay, X denote the number of tosses required, okay, and A is probability of X is 3, B is probability of X greater than or equal to 3, and C is probability of X greater than or equal to 6 where X greater than 3. Find B plus C by A. You see this, my dear friends, a fair die is tossed repeatedly until a 6 is obtained. So, suppose number of trials required is, suppose you may get in the first trial itself, or second trial, or third trial, or fourth trial, maybe indefinitely. What is the probability that in the first trial itself by 216, and P of X greater than or equal to 3 means this sum of all probabilities must be 1 minus, you can subtract these two, which is 1 by 6 plus 5 by 36, which is, my dear friends, 1 minus 11 by 36, which is 25 by 36, which is nothing but, you see, P of X greater than or equal to 3, A is this, B is nothing but 25 by 36. Now, C, my dear friends, C is nothing but, given that X greater than 3, you know that X greater than 3 means 4, 5, 6, 7 and all, you know already, you know that. In this, my dear friends, you want X greater than or equal to 6. greater than or equal to 6 means you just see this is what conditional probability is. In the denominator you will get x greater than 3 means fourth trial. Fourth trial means 5 by 6 whole cube into 1 by 6, 5 by 6 whole power 4 into 1 by 6 and so on. Whereas in the numerator, if you know this, so x greater than or equal to 6 means sixth one, 5 by 6 whole power 5 into 1 by 6, 5 by 6 whole power 6 into 1 by 6 and so on. If you just take, my dear friends, you just take 5 by 6 whole power 5 common here, 5 by 3, 5 by 6 whole cube common here, denominator gets cancelled, you will get 5 by 6 whole square, which is 25 by 36. Third one is going to be 25 by 36, my dear friends. Okay, so you know C value. So you want B plus C by A. 25 plus 25, 50 by 36, that is 50 by 36 you can write, divided by A is nothing but 25 by 216. 25 by 216. You just compute now 36 6 times, you will get 6 into 2, you will get 12 is the answer, right? So here the point is how to compute this probability. This is conditional probability case, my dear friends. Next, let A and B to null events, non-null events such that A subset of B. Okay, then which of the following statements is always correct? If A is subset of B, my dear friends, okay, so P of A must be less than or equal to P of B. P of A given B, that means B will happen, then what is the chance that A will happen? Sure, 1 it is. P of B, okay, minus P of A. Is this correct, dear students? You just see, my dear friends, so just you take the case of getting an multiple of 3 when a die is thrown. Suppose 1, 2, 3, 6 is another event. Suppose this is A, this is B when a die is thrown. What is probability that this has happened? So what is the probability that P of B given A? Nothing but 1. P of B is nothing but 4 by 6 minus 2 by 6. This is not correct. P of A given B is greater than or equal to P of A. Obviously this is 1, so this is greater than or this is correct. Less than or equal to is not correct. P of A given B is also correct. This is the best suitable one. When it is subset, when you know that B happened, 100% you can say that A is happened. So option D is the best option out of these, my dear friends. Of course this is like greater than or equal to, but you can say equal, right? Next, my dear friends. Independent dependent event means if you take two events, my dear friends, A and B, so if the chance of happening P of A given B is P of A, that means the influence of knowing the information that B has happened could not affect the probability of A, so we say that they are independent events, right, dear students? So for independent events, do remember P of A intersection B can be written as P of A into P of B. Okay. Now, if AB are independent, my dear friends, you can also say AB bar independent, A bar B independent, A bar B bar are also independent. Okay. Right. Now, my dear friends, you see some questions over this. A bag contains 6 white and 4 black balls. Okay. A bag contains 6 white and 4 black balls. A die is rolled once and a number of balls equal to the number obtained on the die are drawn from the bag at random. Okay. The probability that all the balls drawn are white. You see, dear students, so there is a die. So first we roll a die. So we will get some number. That many, you see, that many balls are taken. Bag contains these, and the number of balls equal to the number obtained on the die are drawn from the bag at random. The probability that all the balls drawn are white. Okay. Suppose, my dear friends, you see, like you have thrown a die, you got 1. So the chance to get 1 is 1 by 6. In that case, you have to draw one ball that must be a white ball, that is 6C1 by 10C1. Or a die is thrown, you got 2. 2 means you will get probability is 1 by 6. When a die is thrown, to get number 2 is probability 1 by 6. Now you have to draw 2 balls, both must be white. You can write 6C2 by 10C2. Correct. The next, you have to get 3, probability is 1 by 6. Then you have to draw 3, all the 3 must be white. That means 6C3 by 10C3. Similarly, 4 case 6C4 by 10C4. 5 case 6C5 by 10C5, and 1 by 6 into 6C6 by 10C6. You just compute, you will get the answer, dear students. That's it. The next, my dear friends. Yeah, similar kind of questions here. You see, let E complement denote the complement of an event E. E1, E2, E3 be pairwise independent events. P of E1 obviously not 0. P of E1 into P of E2 into P of E3, because he said they are pairwise independent events. So you can write this as P of E1 into P of E2 into P of E3. This product must be 0. And P of E1 positive, that means this cannot be 0. So either E2 or E3 must be 0, my dear friends. The next, given P of E2 complement, you can write like P of E2 bar intersection E3 bar given E1 is equal to. Okay, so my dear friends, so either E2 or E3 must be 0. That is the point. That means suppose E2 is 0, dear students, either E2 or E3, anything is fine. So this is like, you can write E1 has happened. After that you have to get the probability of E2 bar intersection E3 bar. So you can write P of E2, yeah, E1 intersection E2 bar intersection E3 bar by P of E1. Am I correct? You see, my dear friends, because this is given, yeah, P of E2, P of A given B means P of A intersection B by P of B, right? So now, since these are independent, these are also independent, my dear friends. P of E1 into P of E2 bar into P of E3 bar by P of E1. P of E1 got cancelled. One of these two must be 1, because P of, if it is 0, its complement must have 1. So you will get, my dear friends, this can be written like P of E2 into P of E3 complement. So you will get like, yeah, P of E2 complement plus P of E3. This must be like product, my dear friends, rather addition and subtraction. You can say, suppose P of E2 is 1, you can say 1 plus is impossible because probability will be more than 1. P of E3 complement minus P of E2 complement. This is going to be 1 into, so you can write this is, suppose this is 1, P of E2 bar into P of E3 bar. If the question is in that format, this is going to be the answer. Accordingly, you have to pick up, because one of these will be 1 and you will get P of E2. P of E2 bar means 1 minus P of E2, you can say. 1 minus P of E2 means you can write this. 1 minus P of E2 is possible. That is the possibility, because this is, if this is 1, that could be P of E3 bar, right? Next, my dear friends, Bayes theorem or total probability theorem is very simple, my dear friends. You can just see the questions. I'll give you the case how to handle these questions. These will be very, very easy questions, dear students. You see, yeah, you see this, 3 urns A, B, C contain 7 red, 5 black and 5 reds. You see, A, B, C. You see, urn A, urn B, urn C. So contain 7 red, 5 black and 5 red, 7 black. 6 red, 6 black respectively. One of the urn is selected at random and a ball is drawn from it. A ball drawn is black, then the probability that the drawn from urn A. You see, my dear friends, Bayes theorem question itself will be a bit different. Generally, the question should be like, if a particular urn is selected and then a ball is selected, what is the probability that the drawn ball is black? That should be the general question. We call it as total probability theorem question. You see, suppose you do that. Suppose one urn is selected at random, from that one ball is selected at random, that ball must be, my dear friends, black. Suppose what is the chance that this is selected? 1 by 3, and select one ball from this, that should be black, 5 by 12, or this is 1 by 3, black, 7 by 12, this is 1 by 3 into 6 by 12. This is the total probability of getting a black ball. But I just want it from urn A. So, urn A related one you write in the numerator, 1 by 3 into 5 by 12. You just take out 1 by 3 cancel, 5 by 12 by, you will get 5, 7, 12, 6, 18 by 12. So, 5 by 18 is the probability. It's very easy to attempt the question from Bayes theorem, my dear friends. You just write all possible, you just take all possible cases here in the denominator, which is what we call total probability theorem related, from which you want whatever the case you want from urn A, that you write in the numerator. That's it, dear students. Okay. Next, my dear students, you see this similar kind of question. The urns ABC contain 4 red, you see A contains 4 red, 6 black balls, and B contains, you write 5 red, 5 black, and C contains lambda red and 4 black, right. Now, one of the urns is selected at random and the ball is drawn. If the ball drawn is red and the probability that it is drawn from urn C is 0.4, so this is obviously Bayes theorem. Then the square of the length of the side of the largest equilateral triangle inscribed in the parabola y square is equal to lambda x with the vertex at the vertex of the parabola. You see, it is combination of two questions. Up to here it is a probability question from which he is asking us to find lambda. After finding lambda, you see, it is a parabola question. The square of the length of the side of the largest equilateral triangle inscribed in the parabola y square is equal to lambda x. So, once you know lambda, see y square is equal to lambda x is this. So, what could be the largest equilateral triangle that can be inscribed here means you have to put here 30 degrees, accordingly you can find this value, my dear friends. So, how first you try to find lambda, my dear friends, apply, I mean to say Bayes theorem. So, first of all, one ball is to be selected, that ball is to be red. So, first on selection 1 by 3, it should be red in the sense 4 by 10, plus second on selection 1 by 3, it should be red means 5 by 10. Obviously, everything is maintaining 10 means lambda may be 6, my dear friends. Let us see. So, 1 by 3 into lambda by lambda plus 4, my dear friends. This given by, you just want it from urn C means 1 by 3 into lambda by lambda plus 4. This value is given as 0.4, that is 4 by 10. This value is given as 4 by 10. You just take out 1 by 3, dear students. So, you will get lambda by lambda plus 4 by, you see, 4 by 10, 5 by 10, 9 by 10 plus lambda by lambda plus 4 is given as 4 by 10. You just check lambda is equal to 6, because if it is 6, my dear friends, this is 15 by 10, this is 6 by 15 you are going to get, that is you can say 3, 2 by 5, 4 by 10, perfect. So, lambda is equal to 6, my dear friends. Once you know lambda is equal to 6, half of the problem is done. Then you can go with, dear students, the square of the length of the side of the largest equilateral triangle. You know, my dear friend, the parabola is equal to y square is equal to 6x. Now, the largest equilateral triangle that can be inscribed here generally dear students, it must be like, yeah, it must be like, I can say, this is the equilateral triangle. So, this must be 30 degrees. So, you can say this is 90, this is 60, this must be. So, he said y square is equal to 6x means you can take one of the points as at square comma 2at. 4a is 6. So, a is 6 by 4, 2 by 3. at square comma 2at, that is 4 by 3t this is. So, you can find this point, my dear friends. This is x coordinate, this is y coordinate. You see, so this is going to be 60 in the sense tan 30 1 by degree. So, y coordinate by x coordinate, that is 4 by 3 t by x coordinate 2 by 3 t square must be 1 by root 3, my dear friends. This becomes 2 by t is 1 by root 3. So, you will get t must be 2 root 3. Once you know t, my dear friends, you can find this point. T square is going to be 12. So, 3 4 times this is 8 comma t is 2 root 3 in the sense 4 become 8 by root 3. So, you just, this point is the distance. Square means 64 plus 64 by 3, my dear friends. 64 into 1 plus 1 by 3 will become 4 by 3. You just simplify, you will get the answer here. So, the point is probability related question can be answered in this way, my dear friends. Next, so probability distribution or random variable. Here, my dear friends, there will be some variable here x, okay, some variable x, and it will have certain possibilities x1, x2 and so on xn, whose probabilities will be like p of x1, p of x2 and so on p of xn. Now, dear students, each probability must be greater than or equal to 0. Sum of all p of xi must be 1. That is first point. This is called probability distribution, and the mean of this mu is equal to sigma xi pxi, and variance sigma square is sigma xi square pxi minus, so average square. This is the formula to find variance. With the help of this, we can do probability distributions. Dear students, you see this question here. 2 dice AB are rolled. Let the numbers obtained on A and B be alpha and beta respectively. The variance of alpha minus beta is P by Q, where P comma Q are coprimes. Then the sum of positive divisors of P is equal to. You see this, students, the 2 dice AB are rolled. So, A shows some number, B shows some number. Let the numbers obtained A and B denote alpha and beta. So, now he has taken variance for the data of alpha minus beta. So, what is the variable? Alpha minus beta. So, alpha minus beta, you are going to get 1, 2, 3, 4, 5, 6. Alpha minus beta, least possibility can be minus 5. The next minus 4, minus 3, minus 2, minus 1, 0, and it can be up to 5, my dear friends. It can be up to 5. So, now you have to find its probabilities, my dear friends. What is the chance when 2 dice are rolled at a time? 36 cases will be there. Difference minus 5, 1 6 is the only possibility. Difference minus 4, how many possibilities, my dear friends? Difference minus 4 means, you see, 1 5 or 2 6, 2 possibilities, right? 2 cases. Difference minus 3, similarly, difference minus 3 means 1 4, 2 5, 3 6, 3 possibilities. So, 3 possibility. Similarly, difference 2, difference minus 1, difference 0, all the 36 cases will be distributed. The same will happen from reverse order also. So, you will get 1. So, after finding this, you know xi pxi variance you want, first you try to find the mean, that is sigma xi pxi, you just find, you will get mean mu. Then you just find sigma xi square pxi minus mean square, which gives variance, right dear students. So in this way you can find variance, which is P by Q. You can take PQ in the simplest form, that means they are relatively prime. So you can automatically find the sum of positive divisors of P you can find. So this is all calculation. First you could form this table, the problem is done my dear friends. So what is the variable? What are their probabilities? That you need to identify. Got it dear students? Next, you see this question, the random variable x has the following probability distribution, then the value of P 1 less than x less than 4 given x less than or equal to 2. See dear student, first of all sum of all probabilities must be 1. So I think if it is 86, so 6k, 12, 13k, 13k plus 86, this cannot be 86 because probability cannot be more than 1, maybe 0.86 subject to correction. So here are maybe 8k, that is 8k in the sense this is 10k, 21k. So please find from this, so you just find the value of k. Once you find k value, you know all the data. Then what is he asking, you know, given x less than or equal to 2, that means 4k, 2k, k, that means 7k. He wants the case x is between 1 to 4. 1 to 4 means in this more than 1, less than or equal to 4 means the only case 4k. That is my dear friends. So 4k by 7k, 4 by 7 is the probability. That's it. Directly you can answer, no need to simplify dear friends. Okay. Next, binomial distribution in the sense in a random variable, you see, suppose a simple experiment independently repeated n times. Suppose in each trial, in a single trial, suppose success, there will be two parts, success, failure. Suppose success probability is P, failure probability is Q. If the same experiment is repeated n finitely number of cases, then probability of R successes is NCR into Q to the power of n minus R into P to the power of R, my dear friends. This is the point. Okay. So if you know this point, and because the logic is simple, for example, there is a coin, maybe unbiased coin, so that coin is tossed 100 times, what is the chance that we get head 10 times? That means number of trials is 100, you have to get success chance 1 by 2, failure chance 1 by 2 in a single trial. You want 10 successes, you can apply the formula. Suppose there is partially biased coin for which the chance to get head is 1 by 3, tail is 2 by 3, such a coin you have taken. If that coin is tossed 20 times, what is the chance that you will get head 4 times? So to get head, in the sense here success is getting head, obviously failure must be 2 by 3, number of trials 20, you want 4 successes. If you could note this data in this formula, you can find the probability. So this is what we call, my dear students, binomial distribution, binomial probability distribution. In this case, do remember mean mu is equal to NP, variance is equal to NPQ. This is also important here. Sometimes direct questions are given on this also. Right dear students, you see this question, a die be rolled n times, let the probability of getting odd numbers 7 times be equal to probability of getting odd numbers 9 times. So if the probability of getting even numbers twice is k by 2 power 15, then k value is, you see dear students, a die be rolled n times, okay, total n times, the probability of getting odd number 7 times be equal to, suppose number of trials is n, to get an odd number, suppose success, it is 1 by 2, failure is also 1 by 2, because suppose getting odd number is success, 1 3 5 out of 1 2 3 4 5 6, 1 by 2. Now getting odd number success 7 times, he wants R successes, that means P of x is equal to 7 is equal to P of x is equal to 9, that is what he said. That means, my dear friends, NC7 into 1 by 2 to the power of n minus 7 into 1 by 2 to the power of 7 is equal to NC9 into 1 by 2 to the power of n minus 9 into 1 by 2 power 9. In fact, these two are the same, you can cancel. NCR is equal to NCS means either R is equal to S or R plus S is equal to N. N must be 9 plus 7, which is 16, my dear friends. If N is 16, yeah, now the probability of getting even numbers twice is, you see, if the probability of getting even numbers twice in the sense, that means the die is thrown 16 times. Now you want even number twice means, so suppose success is getting even number 2 times means R is equal to 2. So NCR into Q to the power of n minus R into P to the power of R, that is 16C2, 16 into 15 by 2, 15 into 8, my dear friends. This is 16, 15 into 8 into 1 by 2 power 16 is the answer. So you just cancel 1, 2 only to get 2 power 15. This is 4, 2 power 15, 15 into 4, 60 is the answer, dear students. 60 is the answer. Okay, right. In the same way, my dear friends, a fair coin is tossed n times such that the probability of getting at least one head is at least 0.9. It's a good question, an important question, the minimum number of n. You see, a fair coin is tossed n times such that the probability of getting at least one head is at least 0.9. So suppose the coin tossed n times. What is the probability that the coin tossed n times? Okay, what is the probability of getting at least one head? Means total minus no head, all tails. All tails means, so suppose when a coin is tossed, suppose success is getting a tail 1 by 2, head also 1 by 2. So NC0 into 1 by 2 to the power of n. You see, my dear friends, so writing this in equation itself an important. Suppose there is a coin tossed n times. What is the probability that to get at least one head? At least one head means total minus no head, all tails. That means 1 by 2 to the power of n. That is 1 minus 1 by 2 power n. This must be at least 0.9. That means it must be greater than 0.9. Okay, so that means 0.1 is greater than 1 by 2 power n. That is 2 power n is greater than 1 by 0.110. You see, accordingly 2 power n greater than 10 means n can be 4, minimum 4 n can be, because 1, 2, 3 will be just 1, 4, 8 only. So n must be more than 3, my dear friends. The understanding that sentence formation is important, my dear friends. Then next, you see this question, let x be binomially distributed random variable with mean 4 and variance 4 by 3. That means NP is 4, NPQ is equal to 4 by 3. If you just divide second with the first, you will get Q is equal to 1 by 3. Obviously, P must be 2 by 3 because P plus Q is 1, my dear friends. If P is 2 by 3, what is N? So 4 by 3 by 2, which is 6, my dear friends. N is equal to 6. Now he is asking 54 into P of x less than or equal to 2. 54 into P of x is equal to 0 means 6 is 0. Q to the power of n minus r into P to the power of 0 plus 6c1 into Q to the power of n minus r into P to the power of r plus 6c2 into 1 by 3 power 4 into 2 by 3 square. This you need to compute, my dear friends. If you compute, you are going to get the answer, dear students, right? So with this, my dear friends, I can say, yeah, so probability topic out of the 7 subtopics that we are having, so probability distribution binomial theorem is very easy part, you can easily answer. Apart from this, independent dependent events and conditional probability problems as well. Total probability theorem, Bayes theorem problems are undoubtedly very easy. You try these. Okay, dear students. So stay tuned to Infinity Learn by Sri Chaitanya. So catch you with some other topic. Bye.